Thank you. So, hi everyone. My name is Roman, and I welcome you to my talk called Domain-Driven UI here at NDC, Oslo, or online, or whatever. So, it's a catchy title. Another possibility would have been full stack event sourcing, which is also pretty catchy, and it's. I hope it lured you here to this talk. So, I hope that you get something out of this. So, first of all, who am I? At the moment, first and foremost, I'm the father of now almost 6 years old twin girls, and also a pretty happy husband. And my wife is always angry that she's not on this image. But the reason why it's there is basically my kids are basically learning all day long at the moment, and I really like this. And I'm also a type of person that is basically learning and trying to learn a lot. And I like or I learn best when I'm actually sharing my content and sharing what I have learned. And I try to do it with writing, but I'm really bad at writing and I really can't do it in a nice way. So that is why I started a YouTube channel called The Dev Owl, where I'm basically talking a lot about F# and event sourcing and a lot of other topics in there. So if you go there later on, I would be very happy. And also, I started an F# meetup, but then Corona came and we started an F# online meetup, which basically turned into F# Conf, which is a full day conference about F#, which was happening last week, last Friday. So it's also on YouTube. I will post it in the Slack later on if you haven't seen it. I think it was a really nice conference. You need to skip the first 30 minutes because we had horrible technical problems, but so people started to call it actually EchoConf. So, but I think in the end we got it sorted out, and we have really nice and awesome talks there. And also this is a really nice way to share what you have learned and how you can actually collaborate with people, I think. So the question now that you know who I am is, who are you? So normally I see the audience and I don't do it, but you're here and you're here even though it's an online conference, and I'm not sure if you're wearing any pants or anything, so I don't know, but I'm pretty sure because you're here, you're actually beautiful. So thanks for being here at first. And I think you are here at such a conference and I'm trying to learn a lot of stuff. So I think you're pretty curious person, whoever you are. So this is one of my foundations as well. So I think we're a bit alike here. So again, thanks for being here. So let's start with the actual content. So this is a classical 3-tier architecture for building software, right? I left out a lot of the technical stuff like facades and all this stuff, but this is basically what we all know when we talk about 3-tier software architecture. So we have a persistence layer, we have a domain layer, and we have a user interface. And a lot of systems look like this. So we have between the persistence and the domain, there is some kind of ORM, object relational mapper, like Hibernate or Doctrine or whatever language you're using. And then you have some kind of CRUD interface, create, read, update, delete, which is basically the whole system. And the question now is, where resides the logic in those systems? So where do we find the logic? Of course, we need to find the logic in the domain. This is normally where all the behavior should actually reside on. But in those systems, there are other places where the actual logic can reside. So for example, in my experience, a lot of times, or the logic, you can find a lot of logic in the persistence layer. So you have store procedures or some triggers or something else in there. And it's really hard to refactor this thing out if you're switching a database or you're moving a system or you're upgrading a system.
We're not seeing the slides. I'm sorry to interrupt. We're not seeing your screen.
You're not?
Sorry for jumping in. We tried to notify the crew, but yeah.
Oh man, this is really bad. I'm so sorry. Oh, that's the wrong one. I'm sharing this one. Thanks for announcing. Really sorry about this. Better?
Yeah, we missed all your beautiful picture that you were talking about at the start.
Okay. I, I just want to show you who are you. So this is the basically beautiful picture up there. So and also if you want to see this, these are my kids and the devil and the F sharp conf. So and so let's get back to the actual content. So we have this here. I'm so sorry about this. So and then we have a lot of logic also in the user interface. And this is sometimes very hard because you have a lot of cruddy stuff in there and you need to know what is actually happening. And you really don't want this because normally your logic should only be in the domain, right? But there's also one other place where a lot of logic in those systems resides. And this is basically the user, right? So in a lot of systems, a lot of the logic that we're actually need to know or that actually is necessary to run such a system is within the head of of the user. So the user needs to know where we can actually start with the stuff and how we can actually do all this. So one notion or a couple of ideas to actually change this came into when we are talking about technical patterns of domain-driven UI, especially with CQRS and event sourcing. So I guess CQRS and event sourcing are not the newest topics anymore. So when I was talking about this 4 years ago with CQRS and event sourcing, not too many people have raised their hands when I said who used the CQRS system, who has heard about this, who used this in production. But still, I think a lot of people haven't really touched it. And so I'm giving a quick introduction into the topic. So what is event sourcing? So event sourcing has the notion that events are fundamental for our business processes. So domain events. So that domain events are actually describing what is actually happening in our system. And it's basically the notion that we are able to describe all the business processes or everything that happened in our business with domain events. And if we have this notion, if we have this idea, then we can say, okay, let's actually model our business with events, with domain events. Yet let's actually use those events as the basis for our model. And if we are there, we can also say, if we already have those events, let's build a software which has those events as the foundation, as its foundation. So build our software with the events as real as the fundament of everything. And if we're there, we're almost at event sourcing, but what we really need, the next step in there is to basically say, we don't persist any state in our system. What we are persisting are only the events, because this is all that matters. This is the main thing that we need for our businesses. And we don't need to store any state, only those events. And if we have this, we have basically event sourcing. I know this is very a very easy description, but this is the basic notion of this. And if we have something like this, what really event sourcing is giving us is that we are actually never losing the intentions of the business. So if we have a database query, something like update customer set street equals Baker Street in some kind of relational database. Why are we doing this? And what should we do after we have done this? So there is no clear intent in here why we were actually changing the street of this specific customer. So we can scratch this and we can say, well, yeah, it might be that the customer moved. And that's why to a new street, Baker Street. And for example, if the customer moved to a different city or to a different place and we're running a gym or something, we might want to send them a voucher or her a voucher that so that the person can go to the next place with this new voucher. But what if we have actually only corrected the address, so there was only a mistake that was happening there? So in this case, the customer is living there for quite some time now, right? So we don't need to send any new vouchers or any new leaflets or whatever. So this is a big difference when we're actually trying to capture the event, and this is what event sourcing is really good for. So I think that event sourcing is awesome, and I think there are a lot of times a lot of criticism about event sourcing, especially in the last couple of years, last 1-2 years. But still, I think if it's done right, it helps you tremendously. So you have no database scheme in there. There's also the promise of not having any migrations, which is nice, but sometimes you need to think of migrate your events as well. If you have different versions of your events, but still you have no database scheme. And why I think this is really nice is that the data structure, whatever data structure you're using for storing, for persisting your state, so be it a relational database, a NoSQL database, document database, whatever, it does not affect your information model. So your data model does not affect your information model at all. You're only talking about the business. And this is what I think is really, really important. Another thing is that we have no loss of information due to destructive database actions. So a typical destructive database action is a delete, right? A delete or an update, as we have just seen. So we are destructing information within our database. But I think, so of course, a truncate table is also a destructive action, and we don't want to really do this in production if we're not sure about this. But what I think is that also an insert is basically a destructive action, because if we have what we have just seen in the last slide is what we are losing here is again the intent. We don't know why we were actually inserting anything. We don't have this impedance mismatch of having to map our objects, our aggregates to specific tables, which is really nice. And it's not really easy, but it's at least possible to have a different interpretation of the past. So, which is really nice. So if we have a new use case in our system, which is basically just a report for specific data, and we have the whole history of events in our system since the beginning of our system, we can actually use those events, project this into another report or into another form, and we can actually use this new use case just right away, which is really nice. What I really love about event sourcing is what-if scenarios, and this is what is also coming later in the talk. So with what-if scenarios, you can really, in a really nice way, say, let me just see how my system would look like if I would do just this and this and this and this, which is really nice. And how this is done in my case here is shown later. But this is a really nice way, which is hard to get done with a relational database where you need things like shadow tables maybe or something that actually mimic the whole data structure. And I think that testing becomes the testing of the domain logic, not testing of your infrastructure. That's a completely different topic I'm not going to talk about here, but testing of your domain model becomes really easy with event sourcing. So if we have event sourcing, we are only storing the events as the state in our system. So if we use only this, we might get a problem, because for every information we actually want to get out of the system, we need to rerun the whole event stream and project into different things. And this is where another kind of architecture fits in really nicely, which is basically CQRS. So CQRS is called, or is an abbreviation for Command Query Responsibility Segregation, coined by Greg Young a couple of years ago, the term, which basically means that we don't have the same data model for our read side and our write side. So the write side is, what we mean with write side is that this is the side where our domain logic, our behavior resides. This is the state that we are actually storing to know in which state our whole system is. So this is the write side. And the read side is basically whatever kind of information we want to show, for example, to the user. This, whatever page we want to show, whatever we want to project into something and show and use as the basis for new decisions a user can actually make. And in classical systems, these models are the same, which basically means we need to optimize for two different things, right? We need to optimize for the write, and we need to optimize for the read. And this is where then those first, second, third, whatever normal forms of relational database come into play. So you always need to find a balance between let's make it easy for write, let's have fast writes, and let's not have too much duplication in our writes. So if I have a first name somewhere, I don't want to have it in another table again, because if I update it in one place, I need to update it in another place, and I need to have mechanisms that make sure that this will never get out of sync. But on the other hand, on the read side, I don't want to have a lot of joins. I don't want to have so many queries to get some information. My ideal way would be just to have a select star from table and have exactly the information what I need. So here duplication is really good, because I don't want to have 3, 4, 5 different tables where I aggregate all the information from. So what we have here is a picture of a CQRS system. So we have here, I may start the laser pointer. So we have here the command side. And here we have our domain model. And in this case, we have down here, we have the user interface. A command comes in, we have a command handler that is doing something. And in here, we can also do CQRS without event sourcing, but in here, it's already in there. So we have the domain model that actually creates some events, and these are stored with an append-only store into our database. And if we have a new command coming in, we just get all the events that are necessary for this, replay them in some way, which is still pretty fast, even if you have thousands of events, and you can make your decisions. But for the right side, it's completely different, because we have our events in here, and whenever a new event comes in there, we are actually projecting into different read models. So we can have 1, 2, 10, 20 different read models. We can have a read model for every specific use case. If we have a basket where people can actually buy stuff in there, for example, we can have just a read model for the list of things that people have bought in the past. And we can have specific database table or whatever data structure we actually needing to represent this. And if we, for example, need some kind of friendship algorithm, we could use something like a graph database, or we could use something like a document database, whatever fits the use case best. And the great thing is that we can create those things, we can destroy them if there is a bug in there, we can just replay all the relevant events again, which is then really nice. And this never affects our actual domain model. So in here we have only an append-only store, which is really fast, and there's no logic anymore in the persistence layer. And on the other side, we can create all the information that we want. So this is basically the main idea of CQRS. So the question is now, how can we actually implement information? How can we actually get those information out of those events? So this is this side here of our CQRS system. So let's say we have a conference planner. We're actually organizing a thing like F#conf or the NDC Oslo in here, and we have actually a conf planner. And what we have here, it's really not the nicest UI, but the idea here is basically we have a couple of abstracts. People have sent in abstracts, and we are the organizers of such a conference, and we can vote for, we can give different points, or we can say veto, I really don't want that speaker on my conference. And a lot of people can do this. And then in the end, we can finish a voting period, and whoever has the most points is actually accepted to the conference. So this is something that we want to show to the user, right? So first of all, again, the events, as I said, are the foundation for everything. And if we're using F# or any kind of ML language or any kind of language that actually has the notion of discriminated unions, which are basically, if you have never worked with such a language, enums on steroid. So, which basically looks like this. So we have an event type and we have all the possibilities of events that actually were happening in our system. And in there, each case can wrap different kind of information. It doesn't really matter in here. What are you wrapping in there, but you can do whatever. So the events are the foundation for this. But if you say events are the foundation, I think it's a small side rant maybe. I think you should really let me just get my mouse back here, sorry, so that you're not interrupted all the time. If you say events are the foundation, you really need to make events the foundation for your system. What I mean with this is what I see a lot of times, also if I go to different companies and talk to different developers, is that they model errors in the domain as exceptions. So that if something is not going right within our domain, we use exceptions for this. And I think this is a really big problem because why is this exceptional? If something is not working in our domain, I'm not talking about out of memory network errors, your RAID storage was just blown away, whatever. This is an exception, and you really need to raise a panic there. But if there is something expected in our behavior, why should we actually model this with stack traces? Our customer don't know about stack traces. I don't want to know about stack traces, right? So if we are in a conference and I want to add an organizer to a conference, what should happen if the organizer is already added to the conference? What should the conference do? Just get up and flip the table and say, I'm stopping here. This is not really what we want to have, right? So I think it's really important to also model the errors that are expected. They are not exceptions in our domain. In this case, I used a specific error case here, and we have a couple of error things in here where we say, okay, the conference was already scheduled, the organizer was already added to the conference, etc., etc. And this is really nice, and this can really be modeled in a nice way, I think. So, okay, so again, let's build a read model for this site that I have just shown you. So if we have this read model, again, it's F#, and if you have no clue about F#, it should be still possible to read this. So for example, here we have a call for papers that is either not opened, or closed. We have a voting period, which is in progress or finished. And in here, this is basically then the type of the read model, a DDO, a data transfer object. It's the type of the read model for one of our pages, for example. And in here we have a ID, a title, whatever. And this is what we want to create out of our events. So the question is, how can we get this? And we use projections for this. So projections are things that have basically two parts. The first one is an init case, which is just a state. So for example, an empty conference. And the second one is an update function that takes an state and takes an event and returns a new state. And if you write this in F#, it can look like this. We have a projection in here. These are generic type parameters as you have in Java or C# as well. And then we have the init, and the update is a function from state to event and state. And Greg Young put a tweet out like now 7 years ago already. You want to learn event sourcing? It's just a function from state to event and state and returns a state. And this was basically what he was talking about, right? So of course, it's not always that easy, but this is the main notion out of this. So if we have such a projection in here, and we have here a projection, which is the initial conference, and the update is an apply function in here, then we say, okay, whatever event comes in, this is pattern matching. It's basically a switch case, if you have never seen this. If this is the conference scheduled, then which gives me the conference, then I just return it. And if I have an organizer added to the conference, I just put this into the list of organizers. So there, bit by bit, I am actually updating my current read model. And here I'm just basically using, I get a given history, which is a list of events, and then I run all of them, each bit by bit through them, and build the complete read model. So this is the right side, how we can actually do this. I'm not talking about how we can store this here. This is actually how to just build those read models. So now we want to implement the behavior side. So in here, we have a command handler and then the domain, and we get some events in here, as I said, and then we need to create some new events in our system. So again, we have such a discriminated union here where we say, okay, these are all the types of commands that can actually happen in our system. So we can schedule a conference, change a title, whatever. And when we get such a command in our execute function, we also get the event list for the given conference. And then we say, okay, if we want to schedule a conference, we call the handle schedule conference function, or the handle change title function, or the handle reopen voting period function, or whatever there is in there. And if we have this, we need to somehow take the history, make a conference state out of it, and then call the reopen voting period function in here. And again here, then we can, this is where our constraints are. So if we are in an object-oriented language, this would reside in an object aggregate where you have all the functions or methods in there. Here it's a functional language, so we just have functions. And we say, okay, if the conference call for papers is closed and the conference voting period is finished, then we say, no, you can't really reopen the voting period. Then we say, okay, the voting period was just reopened. But in all other cases, the finishing was denied because the call for papers was not closed, for example. And the question is how we can actually get this conference state. Well, we have just talked about projections, and also in the domain logic, we can use those projections to get to a current state of our conference, which is really nice. And so in here, we just return a list of events that are happening when some command was actually done. And if we're doing all this, what comes really out, what comes out really nicely is that we can test our domain logic in a really nice way, especially if we're using this BDD style testing. So BDD style testing, I'm not talking about BDD in general here and what it means to actually live this BDD style of creating software, but the BDD style testing, what I'm talking about here is this given, when, and then. So given a specific precondition, when a specific action comes into the system, then we get this kind of outcome. And with normal systems, we need to, this precondition, we need to set up our system to actually have a state from where we can get to another state. So we might set up some mocks and some data structures in there. The really cool thing with event sourcing is that we only need events. So given a set of events, 1 or 10 or 15, when a specific action, so for example, a command occurs, then we expect a set of events. And this is really nice. We don't need to think of mocking. We don't need to think of doing all this stuff. This is really a pleasant way of actually writing those tests. And if you have a language like F#, you can also write a pretty nice DSL for this. So we can basically translate this directly to code. We can say, given the call for paper was open, call for paper closed, and the voting period was finished, when I finish the voting period, then I expect that the finishing was denied and this was an error. So actually this can be shown to business experts, right? You can talk about this with business experts, and this is really cool. All right, enough of this. So if we have this thing here and we get rid of our old persistence and we use an append-only event store in there, we can actually get rid of the persistence in our system, which is not the persistence in our system, the logic in our persistence. Sorry, we don't want to get rid of the persistence at all. So if we have a look at this, this basically looks like a ring, right? So we have this nice pattern in there. And this is a ring of power, you know? This is really the most powerful ring of software development we have ever seen. And we are so happy that we have it, right? So it's really awesome that we can actually use this thing, and we want to use it everywhere. But the big problem is that so everything is cool. Reads are optimized, writes are optimized, behavior on the backend is one place. But the problem is we still look shitty and no one wants to play with us, right? And our front end, the thing that our actual users are touching, we might have a big problem with this because it's only a backend thing, backend architecture. So we tried a lot. So we tried WinForms, WPF. I'm more from a web background. So we had Angular, React, Redux, and a lot of things in there. And a lot of things were nice. Angular had, especially Angular 1, it's no ancient stuff, but still, it was, for me, it was this first way of two-way data binding. I changed something here, the model is changed, then I changed the model, and this is changed, and this is so awesome until it's not awesome anymore, and you get cascading updates, and you don't know why something is changing because I just changed something here, and suddenly my whole thing, you can't really follow this anymore. And also with Redux, which has a really nice architecture, things like immutability are not enforced, and you get a lot of problems with this, especially when having side effects and all this stuff. So we were really thinking of, man, are we really that bad with user interfaces, or is JavaScript really this bad language that everyone is talking about? And is this really that hard? And so, and then for me, a guy came around, which I really admire, which is Evan Chaplicki. And he said basically developing good user interfaces is not hard because JavaScript is so bad, but because user interface design is actually a hard problem. And he came around not only with an architecture, but with a whole language, which is called Elm. And for me, this was basically, welcome to the promised land. So here I am. This is how I want to write my user interfaces from here on. And this is basically a couple of years ago this happened, and I'm still there, to be honest. So, and one thing is with Elm, what I really admire is this notion of tie your hands to free your mind. You can't do everything all the time. It's really hard to do workarounds in some way. And it's a functional language also, immutability everywhere. It's really nice. So, but what I want to talk about here is not Elm. What I want to talk about here is the Elm architecture or model view update, so MVU. And now a couple of weeks ago, Microsoft introduced MAUI, which they also take the term MVU for, which I don't think it's MVU at all, because this MVU structure is basically based on the notion of immutability. So in there, model view update, I'm going to explain this now. Why is it called like this? We have the model. So the model are only types. It's not the domain model. It's the model of our application, of our front-end application. So we have only types in there. It's only the structure. There's no behavior in there. And the important thing is it's the single source of truth. So this is where all the information about my software needs to be. There's no other place in my front-end application. And then we have the view, which is a declarative description on how my front end should look like, dependent on the current state of the model. So it's not actually changing anything. It's just if my model looks like this, my view should actually look like this. And this is in the back end. In the back, it's implemented with virtual DOM. So what is happening here? Whenever we get a new model, which is always, because immutability, it's always a new model. It's not a mutated state object, whatever. We are rendering a new view, and on the back, we make some diffing so that it's still fast if we create a whole new view. So we are not switching the whole DOM if we are in the web case, for example. Whenever the user is doing something, then a message is sent to the runtime or to a mailbox. So if you know the actor pattern, it's basically a mailbox in there, but you can just call it the runtime. So if the user clicks on something, there is a message sent to the runtime that says, okay, message is clicked. A message was clicked. Or if you have intent in there, user requested the reopening of a voting period. So then a message, this message is then sent to an update function. And this is a pure function. And this basically takes the current state of the model, it takes the message, and it returns a new model based on the message. So based on how the actual thing should work or should look like again. So it's all declarative. It's always, if we have the model, the view describes how it should look like. And if we have a message and the model, the update describes how the new model should look like. And then this whole circle starts. If we only had this thing would be nice, but it would be completely useless because we just had like warming up our CPU. There's nothing happening. I can't really send any HTTP calls over the wire. I can't really have WebSocket connections. I can't really do anything. That is why, based on specific messages, which are called commands that are coming from the update, it's a command that is going down again to the runtime, to the mailbox, and then the runtime mailbox, whatever, is responsible for the side effects. And whenever a side effect is finished, like an HTTP call, it could have an error or could be a success. Then another message gets back to the update function and the whole cycle restarts. And this is a really nice architecture. And the cool thing is that here, you know, this is the dangerous part where things can go really wrong if you do denial of service to something this is just where basically where the side effects reside, where everything can go wrong. But this is handled on the side of your really nice loop. So if you have a look at this, again, this would be F# in here. It's basically, we have the model, which is just an int. So this is a counter where we count up and count down. It's really easy application, of course, nothing to really think about. But the messages, the only thing that can actually happen in the system is increment or decrement. Nothing else can actually happen. So in our types, we can actually describe all the things that can happen in our system. The init thing, so our initial thing is that our model is 0. And based on the model in here, we have a view that this is a DSL for HTML. We have a div with 2 buttons in there. And if I click, I dispatch a message that decrements. I dispatch the message decrements if I click on the minus button, and if I dispatch a message increment if I click on the plus button. And this update function then takes again what I just said here, the message and the model, and returns a new model. So even though there's a plus in here, the language is immutable. So everything is immutable. So it is returning a new model here, and the whole cycle starts again, because then the new view is rendered, and in here I say what the current number is. And if you have a look at this thing here, how does what does this resemble to? Well, it's another ring, right? So we have another ring of power. And I think it's a way more pure and beautiful ring in there, because you can build really nice things for your viewing pleasure actually in there. And it's all pure and immutable, and it's really nice. But now we have a problem, right? So now we have 2 rings of power. Now we have, is this shared here all the time, actually? So now we have this pure ring of power in here. So this can be a problem, right? So this can be a problem because now we have those 2 forces that are actually might fight with each other, right? So we have the power here and we have the power on the other side. And if those are 2 teams, for example, you can imagine the problems that can occur if we are actually having those 2 forces working against each other. So what we actually want, in my opinion, is to marry those, right? We want to actually bring those together and talk and rule together basically the whole system. But then we have a problem, because they might talk about the same things, and they might talk about, in this case here, it's ice, whatever. But if we're not having the same model, we still have we still have misunderstandings in our communication. So it might lead to a lot of very frustrating problems in our system and with our teams. So what we really want to have is to bring those two models as close together as it's actually possible. And the closest thing that we can actually have together is the view. Sorry, is if there is only one model, right? So if those penguins talk about fish, it's pretty clear that they all talk about fish. So the easiest thing would be if actually everyone is talking basically about the same model. Okay. So what if we're actually able to achieve this? What could we achieve then in our system, or how can we use those two rings to work together? Well, we have this shared data model here. And in the shared data model, we said for whatever use case we have, we can actually create a read model. So in here. So what we could do is we could use one read model as the basis for the model of our frontend application, as the basis for our MVU thing. So here as the model in this case. And this is really nice. So then the projections might be written only once, and then you can reuse them here to use this as your shared thing here for your front end thing. And if you're actually sharing the data types and might even share the types and share some of the logic in there, you can go even a step further. So this would maybe allow you to use parts of your domain model for your update function. So just imagine if your system, the network connectivity of your system goes down, and you really want to actually keep working on, then what you need to do is somehow duplicate the logic from the back end to the logic of the front end if you really want to see how your system would look like if you can't really send all the commands to the server all the time and get the results. So, and if you would be able to do this, to share your information and share your behavior, then we could actually marry those systems. So then we could actually use our events of our domain model in our update function in here, which would be really cool if we have the right use case for this. So this is really nice. So then we can actually rule together the world and have a really nice message-based architecture system in here. So if we do this, we still have a problem in here. So not everything is perfect now, because we're still having this CRUD thing here, and all the thing can be done in a CRUD way, but then you lose all the nice advantages of event sourcing, of this nice architecture here. So what we really want is actually, we want to get from a CRUD-based user interface where I have just a couple of radio checkboxes in there, whatever, and some save button or update button, to a task-based user interface where I have specific actions, and I can really make those specific actions because we have the events, we know what the outcome is, so we can describe the business operation, and then we also have the command. So let's make a user interface based on those commands. For example, I want to dismiss my coworker Marco, whoever knows him. I don't want to do this, but this could be a thing. And if we actually do this and have a task-based user interface in here, we can get rid as much as possible of the domain logic in the head of the user, because there are only tasks that actually needs to be done. So it's not if I click here and then there and right click in here and then I can actually save this thing, which is really cool. And the domain logic that resides in the user interface is actually good domain logic because it's shared with the domain. So it's not something that is duplicated or might deviate after some time. And I'm not talking about the logic that a select box should open or something. This is completely a different kind of logic I'm not talking about here. But the question is, this would be really cool. But the question is, how can we actually do this? So the first thing is, yeah, we could keep it in sync manually, but then I think we get a lot of problems if we have the domain logic here and the other logic there, and we need to somehow keep it in sync manually. It's really easy to deviate and have a quick fix here, and this is forgotten somewhere else. So this would be a possibility, but might not be the best one. So another one would to have like a code generation system in your system where you have your backend code and you parse this and you somehow generate your front-end code based on the backend code. I think Haskell has some nice way to do this, and a couple of other languages as well. But we are actually going. Small part of our system is going that way, and it works well. But there are also other ways. So one way I really love to use is a tool like Fable. So it's a F# to JavaScript transpiler. It works for us. It works really, really, really well, and it generates basically readable JavaScript. And you don't, of course, you need to know JavaScript for all the quirks and quarks and whatever happens on your front end, but still, it helps us tremendously with the business logic. Being on the back end and on the front end, and giving us a lot of really nice opportunities, and not having to use also TypeScript, but having a really nice statically typed front end, which is really cool. So what I'm going to do now is I'm going to show you a small prototype how this could actually work, and what you could actually build with these kinds of this kind of architecture in your mind. So this didn't work. So I hope that you can actually see my screen. It looks good, I think. So what we are having here is a conf planner again. And here we have two conferences in here, the B# and the F# conf. And we have a bit of information about the F# conference, the conference title, and we have the available slots for the talk. We have a couple of organizers. It's me, Marco, Geen, and Dylan is doing NDC Oslo, so he's not here, which is good then, I think. And we have our votings. So in here, in here we have basically the possibility to vote for different talks. So I say, okay, I want to have from 0 to F# hero from James. I really want to have in this. So I voted one, or if I really want to have this, I voted 2. And I say, no, I don't want to work with him. Then I voted, I gave my veto. In here, down here, you can then see, okay, I have my commands that are actually running at the moment to my server. And down here, we can see which events are actually coming back from the server. So what this thing is actually doing is, when this whole thing started, it asks a read model from the server. It asks it, give me the current state for this conference that can be shown to a user. So, and from there on, it's used to actually display this to the user. But from there on, whenever I'm doing something, what is happening here is that the actual event is sent back to the client, and it is then used to reuse the prediction from the read model. Because I'm using this basically, I don't need to ask the read model on the server. We can just stay on the client in here and know how this thing should look like then. And if we have another one here who is also opening the F# conf, another client here, now it was asking for the current state of the read model, which is basically the same. And I need to really get this thing here off. Which is basically the same. But whenever now I do something in here, you can see that this is also updating, because now all the events are sent to all the clients via WebSocket, in this case, to all the clients that are actually connected. So now all the clients are basically live and can do and can update their read model or their model of this MVU applications accordingly, which is pretty cool. And also it's the other way around in here. So this is one thing that is really nice. So we don't need to ask the read model, the server all of the time. But what this allows us now is to say basically, okay, if I say here, for example, I say finish the voting period, we see now, okay, Don Syme was accepted and Feline was accepted. and James was not accepted in here. If I reopen this, we see this on both things. But what I want to do now is I want to switch to a what if mode. This could be now, I just want to see how my conference would look like if I have this votes. Is it diverse enough? Do I have the right people? Maybe I want to schedule them for some rooms. So what I could do now, I'm in what if mode now, and now I can change my stuff in here. I say, okay, I want to gain James 2, or Vito for down, and also the 2 for Feline. And what we have here now is potential commands. So these are the commands that might actually be sent to the server. And whenever I do something here, I get the potential events. It's a bug in here. Actually, there should be all the events in there. It's only showing the last one, but they're all there. And what we're doing, we're using now the same domain logic from the server to know which events are actually generated, would be potentially generated on the server, and we can work in a what if mode. So if we say now make it so like Picard, so then all the things are actually sent to the server and everything is done here. I do this again to make it a bit more clearer. I say this, and here the veto, and then I can say finish or voting period. And then in the end, if I say make it so, we can see that here also the voting period is finished. This is really nice, and this is without any kind of shadow databases or any kind of thing. We have implemented a really nice what if situation in there, which really allows me to check how my thing would work or if my network connection goes down. What is also possible, and it's the last thing I want to show, what I think is really cool, there might be, and there are always questions about, yeah, but what about if someone else did something in the meantime, and now you need to have some conflict resolution, because what if two commands are a right, and then the third one was not a right, so there was kind of a domain error in there, and now everything would be different than I expected. Now you can think of some strategies for actually fixing this, but what also could be possible is that we actually say, okay, I go here, and then I say I do this, and then I do that, and I do this, and then I also say I go to organizers, and I say, okay, Dylan should also be an organizer of this conference, and then I go back and say I finish the voting period again. And not all. Oh, okay, this is the bad thing. Okay, I can't really do this. So let's do this here. I can't finish the voting period because not all organizers have actually done something. But still, I have put my vetoes to all of the tasks, for example. What I do now is I go to organizers and say, okay, now here Dylan is also an organizer of the conference, but this is now live, right? So we are here in a different state now than here. So we have a deviation in there because now this is live. So now I can say make it so all. And what is happening now is because there's one error in my whole system, in my whole event stream, it's basically a command stream. So it's basically a command batch that I was sending. And because there is one error in there, none of the commands are actually resulting in a different state of the system. Because we have two errors in here, organizers already added to the conference, and not all abstracts have been voted by all organizers, which is, I think, a really nice way to actually work with those kinds of systems. So you can have a really easy strategy to work with actual conflicts. Okay, so let's go, and now this switched. So this should be good. So I think this is really cool. I really love this. I think this is an awesome kind of actually writing your architectures, writing your applications. But of course, beware the bias. This looks really nice and really cool. And now we want to do this all the time. But this notion of if you have the only thing you have is a hammer and everything looks like a nail, and especially if you have such a powerful hammer, if you have Thor's hammer in here, this is really need to think about, is this the correct use case for this? If you have a completely different front-end team, maybe really sharing the code is not the best one. If you have a cross-functional team for one bounded context, maybe this is the perfect way to go. But really think about it, because even we saw this one Thor movie, I think, where this hammer was destroyed. So even the most powerful hammer can be the wrong tool. So if you got it, awesome. If you ask what can I do now, so beware. This is a prototype. This is not a production ready thing. I think it's the future somehow, but it's a prototype. So the concepts are working. This thing is not production ready, of course, but still now it would be the time to learn, to do your stuff, to do this, to ask me questions if you have any. So first of all, sorry for the technical problems in the beginning. I didn't share my screen, obviously, and I don't know if you have seen your faces all the time, and but I hope that you got something out of the talk. So thanks a lot. The code for this stuff is within the SafeStack repository. SafeStack is a thing of F# front-end to backend, and it's called the SafeConfiner. You can find my YouTube channel on the DevOwl on YouTube. My Twitter handle is Romsen. This is a 0 because the O was not available anymore. GitHub is Romsen with an actual O. So I'd say thanks a lot. I don't know if we have time for questions, but I will be in the chat anyway. So thanks.